trying to see if I can find any material for statistics and probability.
I had some interesting statistics questions the other day from Dylan.
I think I have some.
If you have some, you can send them to me, but they may be the same as his. Let me pull his up and see if you recognize them.
These have the answers on them, but...
What's that?
I think these may have the answers on them, but they could be useful.
Well, Dylan's questions were very unusual. How often do you see a math paper with no numbers on it? Does this look...
Yeah, that's exactly what the, send you.
Okay, you don't need to send it if this is it.
Okay.
Shall we start at the top? 13? Yeah. I don't have the other side. Oh, actually, the top is 10. Whoa. Gee, what happened there? So let's look at 10 and talk about it. Is that a biased sample? Or unbiased?
I think it's unbiased.
It's biased for the following reason.
What?
Who's listening to that station right now?
Oh, country music fans.
Ah, so if they're randomly announcing the phone number to the listeners, most of the listeners are going to be country music fans. So the results they get from their poll will not mean much, right?
Mm-hmm.
I mean, it's like if you were measuring who was Christian and who was atheist, but you were standing outside of a church and polling people that were coming out of church. Well, that wouldn't be a very statistically valid sampling. In other words, you want to make sure you're randomly sampling people. And even though they used the word random in this, they were really not randomly sampling. They were announcing phone numbers to primarily country music listeners.
Mm-hmm.
So obviously, whatever results they get are going to be pretty meaningless, right? I mean, they might get 90% of the people say they want country music, 10% want classical. Well, that doesn't help them one bit in their decision to change from country to classical.
Mm-hmm.
What they would need to do would be a random sample, not of their listeners, but of people. Just go through the phone book. Call them up. Say, do you like country music or classical music better? That would be an unbiased sampling. How about number 11?
It's biased.
Yeah, because they're talking to lobster fishermen. They're talking to fishing people who obviously are going to want no limits on the number of lobsters that you can catch each day. About 12.
Unbiased.
I think so. It seems pretty random. The fact that they surveyed athletes in different age groups.
Yeah.
Well, hold on a second. I misread this last time I looked at it.
Oh, it's only one of the age groups.
Yeah, I misread.
So biased.
They surveyed 5 triathletes from all different age groups. Now,
just one age group, you don't cover
one of the age groups might matter. I mean, what if they were surveying people that were 75 and over?
Yeah.
there might be a preference for Saturday or Sunday. And in fact, the religious aspect enters into it. So if there is one particular age group that is more religious than another, that would not be a random, unbiased sampling. The way they've stated it, where they don't tell you what the age group is, I would say that's probably unbiased. But it kind of depends. I mean, what if the age group was 15 to 20? Well, I would say 15 to 20-year-olds are probably going to be biased towards one of those days. Maybe not. I don't know. The only difference between Saturday and Sunday is probably church attendance. So you would want, if you were organizing the triathlon, I think 12 is unbiased. What I told Dylan was, this is very interesting stuff. This is far more interesting than your normal statistics stuff.
Mm-hmm.
This is real life. In other words, these are problems that people continually try to figure out as to how to end up with an unbiased sampling so that their conclusions mean something. I mean, for question number 10, their conclusions would be totally meaningless. Even if they got 100% response that said they liked country music better, that would be meaningless because they're only talking to people that are listening to a station that plays country music. So the key with a lot of these things is the word random.
Mm-hmm.
Although not always. In other words, there was
like that. 5 random athletes, but it's only from one age group. You need to have it.
That has the key random word in it, but notice that 10 also has the word random in it. Randomly throughout the day. Well, I don't care whether they're random in the day or not. The fact is it's still a biased survey, even though they have the word random in there. Let's look at 13 and 14. Go ahead and read 13 to yourself. Is this a randomized comparative experiment?
Yes.
I believe it is also. What is the treatment?
The treatment is the computer.
I would say using a computer for testing is the treatment.
Yeah.
What is the treatment group?
The treatment group is the half, or is the group of students out of the 300 that use the computer to take the test.
Yeah, and it is half. There's 150 students that take it with a computer, and there's 150 students that take the test with pencil and paper. So the control group would be the pencil and paper people.
Mm-hmm.
And I'm not sure that this terminology is all that important. I don't know. I mean, I've never heard of this terminology before. The treatment group, and the control group. I don't know that's the most important thing you need to get from statistics. The most important thing is to know whether the results have any meaning or not, because a lot of times they don't. People will do these studies and they'll set them up wrong and they won't have any meaning. So it's not an easy thing to do.
Mm-hmm.
The other thing they don't tell you here is what significantly different means. Let's talk about that for a second. Because that's pretty unmathematical, right? Let's say one group averaged 78 by taking it with pencil and paper, and the other group averaged 79. That's probably statistically insignificant, right?
Mm-hmm.
But what if one group averaged 85 and the other group averaged 65? Well, clearly that's significant. In other words, if this is the people on computers, they're doing better than the people with pencil and paper. So obviously, if 78 versus 79, if we're going to consider that insignificant, then, and we're going to consider that significant, well, what's the magic number? In other words, is 75, 80, is that significantly different or the same? They don't tell you. And the whole point of the study of statistics is to come up with the magic number here. And I suspect that you would say if there was a 1 standard deviation difference, then that might be statistically significant. And maybe that is, in other words, 1 standard deviation might be 5 points, but it's probably not 1 point.
Mm-hmm.
And certainly the difference between 65 and 85, that might be 4 standard deviations. Okay? You know what I mean by standard deviations, right?
Mm-hmm.
In other words, you've just finished an exercise where they gave you a normal distribution curve, and you knew that 66% of the area is 1 standard deviation away from the mean. So
2 is 95.
yeah, if that's the mean, then this point is the mean plus 1 standard deviation, and this point is the mean minus a standard deviation. And so when you're 1 standard deviation away, you're including 66% of the data if you're, say, within 1 standard deviation. 2 standard deviations is 95% of the data, and 3 standard deviations is 99.7%. So, let's talk about something interesting for a second. 2 years ago, they discovered the Higgs Boson, which is a particle that had been only theorized based on pure math. 50 years earlier, Peter Higgs theorized that there must be a particle out there called the Higgs Boson. They named it after him, actually. But he said there must be a particle that has a certain mass that exists. Well, how did they discover the Higgs boson? In physics, they require 5 standard deviations to prove something exists. And what that means is 99.99994% probability. Okay?
Okay.
Whereas in our normal distribution, 99.7% probability is found within 3 standard deviations. So if I found a number that was within 3 standard deviations, I would say it's a 99.7% probability that any number I find will be within 3 standard deviations. Well, 5 standard deviations is that number. And that's what physics insists upon before they say that something is a valid discovery. So the reality is that there are no certainties in life, not even in science. In other words, they can't really say with 100% certainty that they discovered the Higgs boson. What they can say is that they have a 99.99994% probability that they have discovered the Higgs boson. But
Okay.
there is still a 0.00006 chance that it's not the Higgs boson. It's just a wild particle that's part of some other particle physics. So this issue of standard deviation is kind of interesting, and you can kind of tell it's totally arbitrary. By that I mean they have chosen 5 sigma as the measurement for truth. If it's within 5 sigma of the mean, then they're going to say that it's real. But there's always this probability right there that they didn't really find the Higgs boson. All right. Just thought I would mention that because it's kind of interesting.
No, that's interesting.
Yeah. Let's look at this more. I don't need my drawing tablet for most of these. Let's look at number 14. Let's read that.
It's not a comparative
No,
experiment.
it's not randomized comparative experiment.
It's not randomized.
And the key is they let the people choose. In other words, the people were given a choice. Well, you don't want choices if you are looking for random. What they should have done was take a group of 60 people and randomly assigned half of them to eat 6 vegetables a day and the other half to drink 12 glasses of water a day. Or 60 people in each group, sorry.
Mm-hmm.
The fact that 60 people chose to eat 6 vegetables a day, well, that takes away all the randomness. In other words, the people that chose 6 vegetables a day probably like vegetables. And the people that chose to drink 12 glasses of water a day probably didn't like vegetables. They also don't give you much additional information. In other words, did they just drink 12 glasses of water a day in addition to their normal diet, or is that all they drank? And the 60 people who ate 6 vegetables a day, is that in addition to other food? I'm presuming yes, it is, just like the people that drank water. And so the conclusion that one might reach incorrectly is that drinking 12 glasses of water a day lowers your cholesterol by 20%, more so than eating 6 veggies a day. And first of all, I think that that's probably not true, but you could not use this experiment to prove it.
Mm-hmm.
For one thing, it's too small of a sample. 60 people is not enough. If you had 6,000 people, maybe it would have a little bit of meaning, but only if they were randomly selected, not if you let them choose. The moment you let them choose, then people choose based on their preferences. So you're not getting randomized samples. The key is to always get randomized samples. And notice the word random is not in that paragraph. 15 is also interesting. Let's talk about that. Is that a good statistical sampling?
Sample's large enough. It's
Well,
randomly
it's
selected.
large enough. And they randomly select 200 people, so it's a random selection of people. And apparently, it turns out that exactly half of their random sample drink diet soda, and the other half do not drink diet soda. So the survey looks legit to me.
Yeah.
And the results are kind of interesting. Sugar cravings are higher for the people who drink diet soda. But you would almost expect that, right?
Yeah.
In other words, if a human body has a certain sugar craving, and I believe we do, whether we're born with it or whether we developed it, I'm not sure, but a lot of humans have sugar cravings. And so the ones who drink diet soda aren't getting their fill of sugar. So I would expect the diet soda drinkers to have higher sugar cravings. On the other hand, they do choose to drink diet soda. So you're not really talking about random groups of people. I don't know. This one's got me puzzled. I think I said something different to Dylan than I'm saying to you. This
doesn't really say anything about an A for them choosing.
No, they didn't choose. In other words, they randomly selected 200 people out of 330 million that live in the country. And it just so happened that half of them drank diet soda and the other half didn't. Well,
Yeah.
just given that information alone, I would expect that the half of the people that drank diet soda probably had higher sugar cravings because they're not getting their sugar fix per day.
Yeah.
And that's exactly what the study determined. So I don't know. I would be tempted to say that it is correct to assume that if you drank nothing but diet soda, you're probably going to have increased sugar cravings.
Yeah.
I think that would be a legitimate conclusion. It's these kind of questions that I've never seen Chatfield do before in their algebra program.
Yeah.
Totally new. In fact, their emphasis on statistics and probability is probably double this year from what it has been in any previous year. Usually I get 1 week of statistics and probability at most from algebra students, algebra 2 students. And this year, what are we going on, 3rd week of statistics now?
Yeah.
Pretty close. Yeah, they've definitely upped the statistics curriculum. Now, number B actually looks like a little better study. They selected 300 people, and then the 300 people are divided into 2 groups based on exercise habits.
This seems completely unrandomized to me, actually.
Well, they're randomly assigned to diet soda or not, as opposed to the previous one where people told the researchers whether they drank diet soda or not. Whereas in sample or in B, they're randomly divided into two groups based on exercise habits. I presume one exercises, one doesn't. And then within each group, the people are randomly assigned to drink either diet or non-diet. And there's no significant difference in the sugar cravings between those two groups.
Well, in A, there's nothing that says that the participants tell the researchers what sodas they drink. It's just saying that they're sorted into, that they're randomly sorted into two groups and told to either drink diet or not drink that.
Both of these models have some value, it seems, and both of them have some problems. And of course, the question says, identify any potential problems with the experimental design and then describe how you can improve it. So that's the goal, is to come up with an improvement in this method. And it seems to me that B is a bit of an improvement over A.
Yeah.
Although, I don't know, these are a little tough. These are tough. This is why real life is a problem, is because it's very difficult to figure out whether you've come up with a statistically valid method. In other words, does the answer have any value? And if the statistical sampling is biased, then the answer usually has no value at all. Whereas if it's completely unbiased, then you might have some value out of it. And I have to admit 15 tests my limit on this understanding of this. I'm not totally sure how we would improve both studies. Why was these two groups separated by exercise habits? Because now you're establishing a link between exercise habits and whether you drink diet soda or not. So that's going to take away from the value of the conclusion, as far as I'm concerned. So, in other words, so what that there's no significant difference? One group was very fit and the other group was not. They were assigned randomly to drink diet or not diet. I don't know. The more I look at B, the more it looks to me like it's totally legit. The only thing is, it seems kind of arbitrary that they were divided up based on exercise habits as opposed to anything else. But I'm not sure. What I am sure is a really long day.
Exercise habits thing wouldn't.
What's that?
You think you wouldn't necessarily want to have the exercise habits in there because you're measuring.
Yeah, exactly. In other words, I would think it would be better.
I think it's completely unnecessary.
Yes, exactly. In other words, the better study would just be divided into two groups, not based on anything, but random. And then within each group, I would think you would want one group to drink diet soda and the other to not, totally. So the fact that people are randomly assigned to drink diet soda or not within these two groups, I don't think that is going to make any difference. I don't think that's going to produce anything meaningful. No, it can't be. It can't. B's got to be bogus. B's got to be totally bogus. And I think A is also bogus. But how to improve them, I'm not totally sure. What I am sure is I hope you're done with statistics.
Yeah, I think I'm pretty much done.
So we can get back to Algebra 2. All right, Cole. I still got you down for 6 o'clock Monday.
Yeah. That'll work this time. It's just I had a SAT prep class that I forgot about, so I had to reschedule.
Okay. But for the next few weeks, 6 o'clock Monday is going to work unless you tell me different.
Yep. And I'll just schedule online if that changes.
Yeah, that's fine. That's fine. You got that down pat. Incidentally, just so you know, if you want to cancel a session, if you go to the email that is originally sent you confirming a session, there's a link on there for canceling it.
Oh, really? I didn't.
Yeah.
Never noticed that.
So you can actually cancel after you make your new appointment. Go ahead and make your new appointment and then go back and cancel. In other words, you can do it independent of me.
Okay.
Because sometimes I won't get your message. In other words, I'll see that you scheduled a Tuesday session and it's Monday, and I'll maybe assume that you're changing the appointment, but I don't know for sure. You might have a big test coming up. You might feel like you need an hour's worth of tutoring on a given week. So I never know until I open up your new session and you have a little note on there saying switching sessions. Then I know. So it's fine the way you're doing it, but there's also a little bit better way to do it where you can cancel it on your own. Okay?
Yeah.
All right, Cole, I will talk to you next Monday at 6.
All right.
All right, have a good week.
Thank you.
Bye-bye.